Hi guys, I hope you're good since last video. In the first part of this video, we will be going over the core concepts in order to not be confused during the bigger chunk of the video, in which we will be going over some more details, each node, conditional edges and functions, helper functions, so more into the nested logic. After the 45 minutes of code detailed explanation, we will start running our graph experiment and use that to understand more how it works. You will at the end of the video understand that you can have more control over your LLM Agentic application and be able to customize it more to tailor it to your business needs. And when it's not possible with some established framework, which are just wrappers of LangChain's ecosystem Python libraries. So focus more on the higher level picture of this video, even if we will go into some details to be able to start proposing to yourself ideas of what you can do or how you could build your own workflow. As always, please like and subscribe. Watch the video to the end and don't miss any part for an easier understanding. It is assuming that you have watched the two previous videos and have created your boilerplate first graph and played with it already. But I will, for the first part of the video, do a little recap. So here we go, we have different components. We have the nodes, the edges, which are the roots between nodes, LLMs, tools, helper functions, and the states. Everything is compiled, all the components here into a LangChain runnable, and we have different methods to run them. We're going to use stream in this video so we can see every step. And for the agent, we have LLM, which is receiving from the previous node. Is reading the state from the previous node. It's going to use the tool node, and after it's going to be updating the state, so for the next node. So it's doing that because there's a set of functions, is aware of this set of functions which are stored in a list. So the tool node knows about this set of functions, and the LLM node also knows about it. And the LLM node will choose the right tool, while the tool node will be executing that tool. That's how an agent will work. Okay, I'm going to just draw very quickly a custom graph, just to explain and go over the little concept that we've seen really quickly, so that we'll be able to jump into the explanation of the code. Okay, we're almost there. Okay, so this graph here is starting with the user. We have nodes, those elements, functions attached to those nodes, the states, which are evolving, conditional edges. So the user sends his query. This node is like a big center. It's going to treat this query with functions. The next node is going to be using it. So all the nodes have functions linked to those. The state will be evolving from one node to another. So each node will be saving its output or last message to the state, just to notify the next node about what's going on. So same for this node. Okay, so here we just need one more row. And the next node will be able to read this state. Here we will be using message state, so just passing one message to another node. And the output will be saved here also. So we get that request using the route, passing from one node to another. After, there is this on the top, in the middle, and down there. Conditional edges, if else, depending on the output of a function, you will get the node moving to, yes, so here also one function. So after the conditional edge, you will get that state updated. You will get that intermediary function, which is going to be updating the state and telling to the graph where to go, which node to use. So it's not very complicated to understand. We have nodes, we have routes, edges. Sometimes it's one function can have several outputs. So we give it, put it into a conditional edge for those different routes that it can take depending on the output. In the meantime, it's going to be updating the state, and the next node will be able to read the state. So each node has functions attached to it, and those functions are going to be implementing the business logic in how to treat the information at this node level and what to do. Functions here, it means tools also, internet tools, any API, any custom logic that you want to introduce into the application. Okay, so I'm repeating a lot, but that's what you need really to understand. So I suggest you to watch the 2 videos that we've done before this one. And now let's start. It's an embedding graph that we're going to do. So going into the details of the embedding, just the embedding side, we'll have a Postgres database, just for you to understand the context. Has a PG vector, the collections, so for the embeddings. We have a UID, which is going to be actually in the Postgres table, and it's going to be saved with the embeddings to reference the source origin from the table. So we will be embedding some content, but in the table we will get even more information about that chunk. Document chunking, custom document creation, and document embedding. So for that, on the side we can zoom into the document chunking, different techniques, PDF loader, transform into a data frame. We can also clean the data, check the outliers, use only quality data, and so on. But here we will be using just the Panda data frame. We will be actually doing our custom chunking method. Zoom on the table creation. So the table will have a UID, content field, retrieve, has been retrieved or not, the ID of the document, but in case of a web page, it will be a URL, and the rest will be the title section. And after here, the custom document, which will be stored into the embedding, the vector. So it will be a dictionary with a UID referencing the table row or table rows, and the content. And after that, we get the embeddings, the document. We'll have the choice between a PDF and web page. And the Postgres database, it will be set there. So we might use maybe a web page. The project folder 3. So we have an app.py, but I'm not going to use it. I'm going to use a test.py where I'm going to import everything. So the state, it's a folder with the state, another folder with all the tools in apptools.py. The data frame, this is more for logging purpose, to see those intermediary data frame. We're not going to see here the Docker agent, but I created a Docker agent to execute code into the Docker container. We have some documents. We have extra scripts, so we're not going to use those ones here. What we're going to use is the libhelper, all the helper functions, which are going to be the chunking module, the embedding and retrieval, the PDF parser. We're not going to use it because I might use web page. So in my query, I'm going to ask for an internet URL. So a query analyzer, the query matching. Query matching will be maybe for the next video, for the retrieval. We have the logs. We get some notes, the PDF, the parser, the past data frames. So we'll have an intermediary past data frame folder, the prompts. There'll be a special folder for the prompts. And after we're going to use here the test.py. That's the one in which I'm going to import everything is needed just to understand how it works. And we're going to go into the details of those libraries after that. Embedding graph. So let's check the graph. You're already familiar with this. We have the states, and after we have the different nodes. So error handler node, get user input node, data frame from query. So here we're going to process the query and create a data frame from it. It's a big center. Store data frame to database. Answer the user. We'll also have this one here, which is a chunk and embed from database. So in my first example, I will be using that so you can see the whole workflow. And after that, we're going to be playing with it. So we're going to stop chunking because it takes 2 or 3 minutes. It takes some time. And we're just going to play with the nodes. So workflow, we set the entry to get the user input. Those are the edges, so the routes from get user input to data frame from query. We have a conditional edge. So we're going to check those conditional edges. So in this video part, we will be going to the details of those functions. So here we have an intermediary function to handle this conditional edge. You're going to get the last message from the states. Is pass or text. So we have a helper function here. Input string, and we're going to check if it is a path. We're going to return path. If it is a string, we're just going to return text. So using those returned variables, if it is path, we're going to go to the store data frame to DB. If it is text, we're going to answer to the user. And we have an error handler. If any error, if it is not a text or pass, that means there's something wrong. So we want the error handler to return this. So this is the error handler, which is just going to take the last message and return it by saying that there's an error. So that was this conditional edge here for the data frame from query. Now we're going to see the chunk embedded and the answer. Store data frame to DB conditional edge. So here you can go to the chunk and embedded from database data, or it will be answering the user or managing the error handling. So this depending on what the function store data frame to DB returns. After the error handler will be answering to the user, and the answer user will be ending the graph. So let's see this conditional edge. Store data frame to DB, conditional edge. If it returns, if there is error in the last message, return the error handler. If there is a success, we're gonna chunk it. So chunk the data frame. I'm gonna save it to the DB. If you have a text, we're gonna just answer the user. So let's uncomment this as we're gonna use it here. So after this conditional edge, depending on what it returns, if we get the success in the message, we're gonna go to the next conditional edge. So from this node store data frame to DB, we get rid of this. We're gonna go from store data frame DB to chunk and embedded from database. So same here, we have a special function for that. We get the last message from the state and we check if there is error in the message, error handler. If there is success in the message, we're just gonna answer the user straight away. So from here, error handler is gonna be following those two ones. And if it is answer user, it's just going to answer the user and end the graph. So in the conditional edges, you just use the function, an intermediary function, to decide and to read the last message to know how it's going to be answering or where it's going to go next. So when we get the user input, we're going to just ask a question. The question, you can change it, but here just let me strip this. And after that, we're going to save that query into the state. And after that, we're going to go to the process query, because that's the next node. After get user input, process user query. We're just going to see how we process the query. We get the last message. We have some variables here because we're going to be using some chunking methods, custom ones, and we're going to be summarizing some parts. So we're just giving it the maximum content length, maximum title length, chunking size, detect prompt template. So we have some templates. Here are the prompts, and this is the detect content type prompt. And here we're gonna just use that prompt, which is gonna return a dictionary. So there will be a URL if the user has an URL, so he will be able to fetch it and to fill this little dictionary form. It's going to also rephrase the question, so the query from the user. And after we have some other prompts, those are to summarize the content and to summarize and to get a title made out of the content. So this is the summary prompt. We will be injecting some variables, maximum and row. And here also we'll be injecting row in the generated title prompt. And the maximum the maximum number of characters that we want for this title. So here we just see those prompts, and after that we will see in the logic when they're going to be used. Okay, and after we just ask it to put his answer between markdown tags. So answer putting text in markdown tags using not more than number of characters to summarize this, and we're going to just give it the right database row. So those are the variables. We also use the chunk size here, which is going to be used here for the data frame rows, so to determine the chunk size for each row. That's the LLM. I'm going to use Grok Mixtral 7b. Detect content type. So here we can see the detail of this function. So as I showed you initially, it's going to be returning to us a dictionary. That's what we want. And the query analyzer. Detect content type. We're going to go into the details now. We get the query, we get the prompt on the LLM. Okay, LLM, the query, and the right prompt. And we're going to transform the string dictionary, because it's going to be returning a dictionary but in a string. We're going to use the AST library to just eval it into and put it back to a dictionary. We're going to return a dictionary so we can fetch the different parts, different keys. So as I told you, each node is a big center where we're going to be processing a lot of stuff. So here we get the query. It's going to go through a query analyzer. We're going to just here build the system prompt using the prompt system template. And here the human, we're just going to use the query. And after we're going to put it into a list. And we're going to put this list into the invoke method with the LLM to call the LLM with those messages and get the answer. And here we normally get a string, that is a string of a dictionary that we're going to just convert in the other side into a normal dictionary. Okay, so this dictionary here, content dic, we get the dictionary. If there is a PDF, so if it is filled with PDF, so URL or PDF, I showed you this function. So here this one is going to check URL, check if it's a string. So here we have URL pattern. We just use the regex here to check if it is a URL. We return URL. If it is a PDF, we return PDF. We just use the end with here, but we could also use here if string lower start with HTTPS or HTTP. But I'm using the regex. Just trying different ways. And after that here we get the returned value of the function, and we check if it is a PDF or if it is a URL. So here the dictionary is URL is false because it's a PDF, and here this URL is going to be true as we have an URL. So we're just going to using this if else statement in order to create different data frames depending on what it is. If it is not a URL, if it is not a PDF, it's we're just going to get the question. In case the question, maybe the LLM miss it and don't summarize it, we will just get the initial text, the initial query from the user. So here, get final data frame is the function. This is going to take the URL or the PDF, maximum content length. For the PDF here, I'm just adding 200. But here is just maximum content length, maximum title length. There will be the chunk size. Okay. There will be the text summary prompt. Where is it? Text summary prompt. This one here we're going to use. Summarize the content and summarize the title. And the title summary prompt. So we're going to go into this process user query get final data frame. So we want here to save different chunks of the content in the data frame. So if it is a URL or if it is a PDF, it's going to be doing different in a different way. So for the PDF here, it's just going to be using the PDF to section function. And for the URL, it's going to be using the scrap website function. So those are the processing, the parser. Scrap websites. We get the URL. We use beautiful soup. We get the title, the contents. On here, we're just going to be looping through, extract all the text. And after we're going to try to get those contents, join those. So the text here, it's going to be, we're going to append those elements to the text list. And the result will be this dictionary with text, section, and URL. If it is PDF, in the other one, it will be a PDF. But same, it will be text section also as a key. So for the PDF to section here, get the PDF path. We use the library PyPDF. And after we get the pages, we have some different functions with some regex to check if it is a title, bullet points, a table. This one is for the table. And after the lines, so here we're gonna loop through the lines. And after, if there is a line, we're gonna check if it is a title. And if it is a title, we're going to be appending the dictionary, joining the section buffer, which is the list. So text, section, and document. And here we're going to empty the section buffer. Current section line, the line, and after we keep going like that, we check if it is a bullet. If there is bullet points, we're going to append to the section buffer, bullet points. Same for the table. And we just keep going like that. Otherwise, we just append the line to the section buffer. So after having processed those lines, we're going to do the last append. So appended here with a text section and documents. And the PDF path. So instead of a URL here, it's going to be a PDF path at the end. So here document path, well here it's a URL. So after, what we're gonna do, we get the web page, we have scoped it, or if it is a PDF, we have the sections. And we're gonna get some chunks. So we just make a list of data passed to a dict. So we put the web page data into a list. And the chunk size, that's the one I showed you before. Custom chunking for web page parsing. So here we create the chunks from a web page. So this is that function, we're going to see it later from the database data. But here we're going to use chunk text data function, which is this one. That's the bigger function that is going to be handling this web page data. We get the data dictionary. We get the chunk size. So here we have text, the section, and the URL, so that we get from the dictionary. After we check the words, adding next word. So we just keep adding until it exceeds the chunk size. After we're going to append it to the chunks. And after we add here the last chunk, if there is any remaining. And we're going to return all the chunks. So that's how we get our list of dictionaries. And we're going to create a data frame from that. So here I'm just limiting it to 3 records. Otherwise the video is going to last. It's going to be too long if I do the whole web page. So PDF to sections. So this we've seen it already. So we get the data frame also for the PDF data. So that's the function I showed you before. And at the end, we get the same kind of dictionary in a list that we're going to use to create a data frame. After that, we process user query, content summarization. We're going to create this data frame 2 new columns with the summary of the content. So the apply axis 0, which is going to take each row. We use a lambda function and the summarize text function, which is going to be taking as argument LLM row maximum content length on the text summary prompt, which is this one here, system template, and we get answer, put in the text and we say using no more than number of character, summarize this raw text. So maximum, raw, that's the two variables that we need, the raw here and the maximum here, which are going to be injected by using in the prompt, so using the eval function. So that's the text summary prompt, system template. All right, that we put in this function here, and we use the eval so that the raw and the maximum will be replaced by the right values. And after, we're just gonna invoke the LLM with this prompt. So after that, we get the response, and we're just gonna get the response content. And this will be the summary for this row. So we're going to do this for each row. We're going to summarize the text. So same for the title, using the same logic, using the eval. And the prompt, we're going to inject the row and the maximum into that prompt. Row and maximum. The prompt is that one here, generate the title. Please create a title in no more than, we see the number of character. For the row, we use the row section and the row text. So we put them together so we can get a nice title. So this title here is the same. It will be creating those new columns. We have an ID column also, using the UIDs for the range length of the TF. So that's how we create those IDs. If it is a URL, as you know, we have so we're going to have a document name. We're going to use the URL or the PDF document name to fill this column. So that's what I showed you initially with the database, the different fields, but we're going to create here a data frame first that we're going to save, and after we're going to inject it into the database. If it is retrieved or not, the content will be the DF summary. So this data frame can be huge, so we can't save it to the state, but we can save the path where we have saved it. And here we get a final data frame with all the columns that we're going to create using the column that we have already created. So ID, doc name, title, content, retrieved, it's a boolean, yes or no, true or false. So we're going to be compacting this data frame. We're going to use it using some .packet file and the function to just transform it into a .packet, and another function to get it back as a data frame before saving it to the database. So we get this final def, which is going to be saved here in the past data frame as a packet. I will show you the function for the packet after that. We just follow the processing query, everything that's happening in there. So now we got our data frame. We need the path. We need to save it. So here we have this part. If it is a question, we don't need to create data frame. We're just gonna reformulate the question, and here we save it as a data frame. So save data frame has a packet file. That's the function. Get the df, get the directory path, and we're gonna get the file saved here to this past data frame folder, and at the end we're gonna return the file path. So df saved to pass, and that's what we're gonna save in the state. So that will be passed to the next node. So now we're done with the bigger function, which was the process query function. So we have treated this query, rephrased it, summarized the document, put it in the data frame. Now we need to store it to the data frame. It's another node doing some other work. Getting the last message as usual. So getting the path. That's what has been. Has been saved in the last state message. Load the data frame. So we just reverse what we did before. pd.readPacket method to get it back as a tf. Table name. So here I'm getting from the environment variable, but I might get actually most of the variables from environment variable. So I need just one place to change those. So we just check that it's a data frame. After we ensure that the table exists, we ensure that pgvector extension is available. We check if document is already exists in the database or not. So here, if the document already exists in the database, we're gonna ask to the user if he want to update it, or so we're gonna fetch it here, do exist, check if it is filled with something, and after document already present, do you want to update it? Yes or no? So depending on what is gonna answer, we're gonna be here returning something to the state, or we're gonna keep going and saving the data frame to the database. Okay, so success, document already exists in the database, user choose not to update. Okay. And here we ask him, do you want to store it or not? So after here, we get from the data frame the index on the rows. So we check if the content is not already exist in the database. Because if we decide to update, we just want to add what is missing. And after here, we're just going to inject the row. From the row, the ID, the document name, the title, the content, and if it has been retrieved or not. So it's initially set to false for the retrieval. But in the next video, we will be adding the retrieval part. So it will be changing to true. And after we just give a success message to say that the data frame has been saved, or we can also return an error. So if we get a data frame from the last message here, we do load the data frame. So from the last message, but maybe we don't have a data frame from the last message. So at this time, we're just gonna get that last message, and pass it as a text. You see here I put text. So that's what will be used by the next conditional edge. Which here is going to be checking if there is success or text. You see here, success, error, or text. So that's how it's going to be deciding to answer the user or to chunk it for the next node. Okay, so we've seen store data frame to the DB. Now custom chunk and embed to vector DB. So the data frame now is stored in the table called test table. I can use also here environment variable for all the variables. So I'm not really consistent here, but yeah. It's better to just use environment variables so you can change all those variables in one place. Okay. So here what we do, we're just gonna go through the database and create embeddings from what is the database. We fetch the documents. So fetch documents in the same node. This is the first job. Get the table name. We connect to it. We select all. We fetch all, and we return row content. So we do a dictionary. We just create this dictionary here that I showed you before with the UID and the content. So we're going to get a list of dictionaries. So for rows in rows, get the ID and get the content. So the ID is the row at the position 0, while the content is the row at the position 3. So you see ID 0, doc name 1, title 2, content is 3. So that's what we want here, and that's what will be embedded. So we get this huge list with all the rows. I mean those dictionaries of UID and content. And after we're going to inject it into this function here with the chunk size. Say 500. And we create chunks using the create chunks from database data. So that's the second job of this node. Has fetched everything, and it's not here. I'm not in the right file. Yes, it's the chunking one. Chunking module here. So here we go, we got the function here. We got the rows and the chunk size. So that's the function that we need to use. Create chunks from database data. This part, ignore it for the moment. You have the chunks here with the S and chunk without. Current size is 0. So what we're going to do, we're going to append. We're going to first do the little for loop into the list of dictionaries. We're going to get the doc ID. Okay, after we're going to get the content. Those are the two elements. And we're going to get the length of the content. So in the chunk, we're going to append here on this one, the little one. We're going to append the dictionary. Okay, and after we're going to update the length of the current size. So we're going to keep doing that as soon as it is not reaching our chunk size. When it reaches the chunk size, so now we're going to go in the middle of the function and talk about this part. So if the current size plus the document length, so the new document coming, is bigger than the chunk size, and there is something in the chunk list, okay, at this time we're gonna be appending to the chunks, to the bigger one. Why we do that is because we want several rows to be representing one chunk. And we also want the last row of the previous chunk to be the first row of the new chunk. So that's why here we're creating a next chunk, getting the last. So here that's what when we ensure that the last row of the current chunk is the first row of the next chunk. So that's what we're doing here. That's why we're appending that one after having created it. So there's a bit of processing here and shifting. And after, when we start the new chunk, it will be starting with the last one added. When we update the current size to the length of the little chunk. That's how we get our chunks and simulate our overlap. This is kind of overlap to have this last row being the same as the first row of the next chunk. So each chunk is going to be a group of rows. That's how it's going to work. So the second job of chunking is now done. So in the data frame, I used also when I did it, when I created the data frame, I used the chunks. Create chunk from web page data, which was another function, just to not be confused. So I have two different functions, one for the web page data and the other one for the database. So one to create the embeddings, and the previous one that I showed you earlier, that was to create the data frame, so to save to the database, to create those initial rows. While here, the function that we have just used now was the one just to create those new document, custom ones with the UID and the contents. So we have created those chunks, we got them. Okay, so we're gonna go through those by looping through those as it returns a list of list dictionary. So we're gonna embed now. Embed all documents. So we get the documents, collection name, connection string, and connection string. And the embeddings that I'm going to use, the Oliama embeddings with Mistral 7B, 4096 dimensions. So we get this document, we put it here, we create a custom document, and we're just gonna add it to the vector database. I have several separate functions because I was testing and I wanted to do different jobs. But here you just use the vector db create directly. You put the list, and here you got your embeddings, document, connection string. So everything you need to store those. And after we get a success message to say that it has been embedded, or we can have also an error message. So those are the keywords. After we get the final answer to the user. Answer user node. Answer user node is not very complicated. We just answer the user with the last message. Having a little break, and then we start straight away. So now we're gonna be running it. Let's run the graph. So we are done with the coding part. Just now we're gonna be experimenting. Do you need any help? Any PDF documents or web page to analyze? So this sentence you can change it for anything else. Don't focus too much into the details of the sentence. Just let's see the process. And I'm just gonna say I want to know if chickerhouses.com have modern Japanese living room. So here we're not gonna get the answer to this question especially, but what we want to see is all the embedding part, because we're in a video on embedding graph. So we want to see if it's going to be able to recognize that's a website and to do all the processing. Same for PDF, but in this video I'm going to use website. Get user input, step 1. So we got the initial input. We're going to be going slowly through it so you can understand how it works. So graph embedding or PDF, so it's going to be checking if it should continue. Here we get the dictionary. See the string which has been transformed into a dictionary. There's no PDF, there's the URL, has been reformatted. The question have been rephrased. So this dictionary here that I showed you earlier. So web page data. There's a lot. This we can pass it. We don't need to read through. But we can see that there are some different prices. See here and here. There's a lot of /n's. But yeah, we could fetch what is present in that website. Okay. So while looking at this, you can also like and subscribe. So please like and subscribe. I forgot to say it during the break. So what do we get here? We got a data frame, CDF, text colon, section colon, URL because it's an internet website, otherwise it will be written document. The prompt content, here it's good to print this just to see that the variable have been injected. 200. And after we have the content. You can maybe check the prompt just to as a reminder. So maximum, and which one is this one? Maximum, and we get the text from the row. Okay. And this is coming from the summarize function. Here, the maximum length, which was 200. Just let me check here, summarize, we found it, and the eval function that we use to inject those variables. So this went in the right direction. Okay, so we got that. So I'm taking a bit of time here just to go over it so you can see it properly. Okay, because the terminal is a bit a mess. And also the embedding are happening at the same time. So I'll be showing you after. After here, the content, you see it's in a markdown. We have fetched it. After we have for each row, that's why I printed just 3 rows. I just limited to 3, so we can do a demo of it easily. So those are the data frame columns, content, retrieved, ID, doc name, and title. So data frame is here, and after we add the step number 2, data frame from query. Just going to connect to SQL. We're going to check if it is saved correctly into the database. So those are the tables available. Our test table, embeddings, collections from LangChain. No, I'm already the vector DB. So just let's select all from test table. Let's say here I put limit 10, for example, but we have only 3 records. But when you check in, just limit it, because your table might be very long. And let's put this, okay. So this is the table. Doc name, title, contents retrieved, so everything is fine. And we get 3 records. Okay, retrieved 1, 2, 3. So those are the 3 records. Parsed data frames and the CSV. So here I can check the URL CSV. So I just printed that using the code just to see. So that's what is in the table. And that's where we have limited it to only 3 records. Okay, so this is fine. Here we have our 3 records. So everything has been saved to the database correctly. And those are the little chunks that we've done to save to the database. So we get the saved path of the path data frame in the packet file. So this path will be used by the next node. Data frame saved as packet file, path data frame, and this is the one, 2C, 7C, and so on. And that's the same here that we have 2C, 7. So as now we get it saved to the state, to the data frame from query. That's the processing, the big node doing the huge processing work. After here we have deserialized. So we have transformed this data, which has been saved in a packet file, into a data frame again. So maybe here the improvement that I didn't put is maybe to, when everything goes well and we arrive to the end, to delete those packet files so they don't take any space anymore, because we need those just to not have the state with a huge documents. And after here, step 3, we got the success, and the document has been saved, Postgres database. And here you can see the documents printed in the meantime before the embeddings. Here I get this message. It's an error message, but we're not using vectors in the normal table as a field. We're using the collection, which is using PG vector, but it's suggesting to save it as a JSONB instead of JSON. And after we're gonna start chunking. Success. So we got the keyword success. So it's gonna be answering the user and success. Let's check those embeddings. So, where are they? Here. So we have 2 lines. That means we have 2 embeddings, which is correct. 1 and 2 documents. And those are the embeddings. So this has been saved correctly. We can quit this. So those are the embeddings here. Using Olyama. After we get this image, there's more arrows than what it should be. So we start, get user input, data frame from query, store data frame to the database, chunk it. If there is an error, we answer the user, or we can answer directly to the user if there's no error. And after that, there's the final answer down there that we don't see here. There's too many arrows, is because I still have the example of what I've done before. So this is showing several graphs. Just gonna comment it out. So the chunking module that we had, this node, now we're going to be commenting it out for the next experiment. So we had its conditional edge. Just gonna close it. We're just gonna play with the graph a bit. There's no more chunking module, so it's gonna be quicker to run. Okay, we got our demi question. I just want you to see the interruption of the graph when we ask the question to the user and how it behaves. Because now we're going to be storing into the database the same data coming from the same URL. So which cells are available now on checker houses, blah blah blah. And now you see here we got the question down there. Document already present in database. Do you want to update it? So that's what we had here. So if it already exists, we're going to ask to the user. So you can use inputs inside of your graph. It's okay. I mean, I'm going to say no. You see, it's going to be just going to keep going. It's not going to crash your app doing that. Because there's some other ways to do that also, by interrupting the graph, running your question, user input, and after keep going into the graph. So here, for example, we said if it is a success, we go to the chunking, but now we're not chunking anymore. So you see the node chunking doesn't exist. But I put it in the function, so it didn't take that route, it didn't crash the graph, because we didn't use it, but it's better to comment it out and to put the right node. For example here, just answer to the user, whatever. I'm just gonna get the same question. Let's clear this. I'm gonna do the same. I mean, I'm gonna say no. It's not gonna chunk anymore. It's just gonna answer. As I said, if it is a success, just answer. As we have changed the code, we said just to answer. Wait. Let's put this back. Okay, so error handler. Answer the user here. I'm going to put error handler instead here. So I'm going to do it again. Just to show you that now it's going to go to the error handler. Just for you to see the conditional edge and how it works. Now you can play with it. So at the end, I'm going to get the question. I mean, I'm going to say no. And we're going to get here the error. Okay, so I'll put it back how it was initially. Is answer user. So error handler answer the user end. So that's why it's repeated twice. So you've been patient, you've seen the whole video. I'm just gonna be talking a bit. So what is good is that you can start your graph with only 2 nodes. Then you can make each node becoming a processing center by having those functions behind, or even jobs coming back to update the state with new information. So my advice would be to have each node being able to work as a standalone. Therefore, you might want to test the function alone and see if it does what is intended to do, and have all its helper functions in place. And after that, it has an input and provides an output following your business logic. Next node would use that output to process the next business logic. So after having those standalone nodes working fine, just connect those using a root edge. If you have several outputs possible to a node, use a function which will be separate and dedicated only to capture that output. Therefore, use a conditional root edge. Depending on the output, the next node will differ. So it will be going to different nodes. So play with that, adding agents with tools. So here, because of the long code review, I did get the complexity of adding an agent to it off the frame. So it's just for you to understand it a little bit clearly, because otherwise it's going to be adding too much complexity to it. But in the next video, we will be using one graph after the other. So it will be a multi-graph workflow, and we will have some agents using internet tool, for example, or some other tools if needed. The possibilities are limitless, but we will keep the scope to something advanced but not confusing and not too complicated. Okay, that's it. So let's stop here for this time. Please like and subscribe, and see you next time.